In this video, we'll talk about ellipses in polar and rectangular form. And let's talk about this example. Let r equal 8 over 4 plus cosine theta. And let's solve a, b, c, d, e, f. A, find e. So in order to find e, we are going to rewrite the equation. And then we are going to divide top and bottom by the reciprocal of the constant, so by the reciprocal of 4. So 1 over 4, 1 over 4. When we divide, we get 2 over 1 plus 1/4 cosine theta. That makes the equation, it writes the equation in a standard form, which means E it's equal to 1/4 because E it's equal to the constant in front of the trigonometric function, which makes the equation star the equation of an ellipsis. The conic is an ellipsis because E that we obtain is less than 1. Let's do part B, where we want to find D. So the equation that we had was 2 over 1 plus 1/4 cosine theta, and we know that DE is equal to the number at the numerator, so it's equal to 2. But E is equal to 1/4, so this means we are going to get the equation D times 1/4 equals 2, which means D equals 8. Which means the one directrix equals x equals 8. So that's a line. Formulas that connect A, B, C, D, E, like C equals AE and D equals A over E, work only if the parabola or ellipsis or the conic is centered at the origin. So in order to find the A, B, and C, which is part C, we're going to do part D first. So write the equation in rectangular form. So we start with r equals 8 over 4 plus cosine theta, and we want from this polar form to write it as rectangular form. So to do that, we multiply both sides by the denominator, so we get r times 4 plus cosine theta equals 8. 4r plus r cosine theta equals 8. R cosine theta is equal to x, so 4r equals 8 minus x. We square both sides and we get 16r squared equals 64 minus 16x plus x squared. We know that r squared is x squared plus y squared. So doing the algebra here, we get 16x squared plus 16y squared equals 64 minus 16x plus x squared, which means 15x squared plus 16x plus 16y squared equals 64. So right, I use this and this one, and I use this one, and I copy this, and I left it equal to 64. So what I'm going to do next is I'm going to complete the square here. So first I'm going to factor out 15 and get x squared plus 16 over 15x. And then I want to add, I want to add half of this, which is 8 over 15 squared. So I'm going to add 64 over 225, but when I add it here, I'm going to subtract it on the other side. So 15 times 64 over 225 it's 64 over 15. So now we balance the equation, plus 16y squared plus 64. So this becomes x plus 8 over 15 squared, and this one is 16y squared equals, and when we compute this we get 64 times 16 over 15. So now we are going to divide both sides by 64 times 16 over 15 to get equal to 1 and to have the equation of ellipses in standard form. So we have 15 times 15 over 64 times 16 times x plus 8 over 15 squared plus 16y squared times 15 over 64 times 16. So we get x plus 8 over 15 to the second divided by, so over 1024 over 225 plus y squared over 1024 over 16 times 15, 240 equals 1. So what that means, it means if we look and compare with x squared over a squared plus y squared over b squared equals 1, we see that a squared equals 1024 over 225, which means a equals plus minus square root of 124 over 225, which is plus minus 32 over 15, and b squared equals 1024 over 240, which makes it b equals plus minus square root of 1024 over 240, which is plus minus 32 over 240 is, let's find out. So 240, it's 2 times 120, 2 times 60, 2 times 30, 2 times 15, 3 times 5, so 2. So it's 4 square root of 15, which makes it plus minus 8 square root of 15 over 15. So we found the a, b. We can also find c squared as a squared minus b squared. So c squared equals 124 over 225 minus 124 over 240. So it's 124 times 240 minus 225 over 225 times 240. So we get c squared equals 124 times 15 over 225 times 240. Now this is 32 times 32. I'm trying to simplify without using the calculator. And 240 we saw it's 16 times 15. So this cancels with this and we get 2. So we get 64 over 225, which makes it c equals plus minus 8 over 15. So basically what we obtained from this equation, we obtained an ellipses, and this is 32 over 15 squared plus y squared over 32 over 4 square root of 15 squared, or 8 over square root of 15 squared. So we obtained an ellipsis that has the center at negative 8 over 15, 0. So it was shifted, the center was shifted 8 over 15 units to the left. So let's graph the ellipses. Well, the center is, let's call this negative 8 over 15, 0. So this is the center of the ellipses. Then the vertices are at negative 32 over 15, 0, and at 32 over 15, 0, but they are shifted 8 over 15 units. So that makes it the actual vertex is negative 32 over 15 plus negative 8 over 15. So that makes it negative 40 over 15, 0. Or if we divide by 5, 8 over 3, negative 8 over 3, 0. And this second vertex is 32 over 15 minus 8 over 15, so it's 24 over 15, 0, which is divided by 3, 8 over 5, 0. So I transform the fractions into that to be able to graph them better. So negative 0.53 it's here, so negative 2.7, that would be like 5 more. So 1, 2, 3, 4, 5, and then 1.6 would be like 5 more again, 1, not 5 more, 3 more, 1, 2, 3. So negative, so 1 and then 1.53 basically, and 1 more to get to 1.6. So, and then we know that B was, what was B? B was 8 over square root of 15, or 8 square root of 15 over 15, which is approximately 2. So then we go up 2. So we go here, and then negative 2. And so V1, V2, we are constructing the ellipses. And here is the ellipses, the graph. And we can also locate, well, 8 over 15, it's 0.53, so it would be here, the foci or foci, F1 and F2. Sorry, not there, that was the center, so this is the center, and F1, so F would be at negative 8 over 15, 0 if it was centered at the origin, but it's not, so it's negative 8 over 15 minus 8 over 15, 0, so that makes it negative 16 over 15, 0. So that's the double. This would be f1. And then f2 would be at 8 over 15, 0. But because it was shifted, it's 8 over 15 minus 8 over 15, 0. So that makes it 0, 0. So sorry, this one was f1 and f2. This doesn't mean anything. It's just a point. f1 and f2. And here is the center. So now let's check with the calculator. If we go to y equals and we write the equation, 8 divided by parentheses 4 plus cosine theta, close parentheses, twice, and we press graph. This is what we get, and it is the ellipses that we are looking for. We can see how it's shifted a little bit to the left. I hope this helps.